Imagine a world without the Mediterranean Sea. No blue waters, just a vast, sun-baked basin stretching for thousands of kilometers. This isn't science fiction. 6 million years ago, the Mediterranean vanished in a real-life planetary drama, the Messinian salinity crisis. The sea that nurtured civilizations became a deep, dry wound on Earth's surface. The Mediterranean is almost landlocked, connected to the Atlantic only by the narrow Strait of Gibraltar, a tiny faucet for a giant bathtub. When tectonic forces turned off that faucet, the sea dried up, transforming a vibrant ecosystem into a harsh, desolate landscape. For centuries, we thought the Mediterranean was permanent, but Earth is restless. Its history written in rocks and fossils. Scientists have pieced together this story: immense geological forces, life adapting to extremes, and a cataclysmic flood that revived a lost world. Join me as we travel back to the late Miocene, when our ancestors were just emerging in Africa. We'll explore the forces that sealed off the Mediterranean, descend into its hottest, driest depths, and meet the strange creatures that crossed its barren floor. And finally, we'll witness the epic flood that brought the sea back to life. This is the story of when the Mediterranean Sea died and was reborn. The Mediterranean's disappearance needed two accomplices: shifting tectonic plates and Earth's changing climate. The African plate pushed north, colliding with Eurasia, raising mountains and the land around Gibraltar. This rising land formed a dam, slowly choking off the Atlantic's flow into the Mediterranean. The sea was isolated, left to evaporate under the relentless sun. But tectonics weren't the only factor. Climate cycles played a crucial role. Earth's orbit and tilt, known as Milankovitch cycles, caused long-term shifts between wet and dry periods. During wetter times, rivers and rainfall could briefly replenish the basin, but dry spells were catastrophic. With the Atlantic gateway sealed, evaporation outpaced inflow, and the water level plummeted. The crisis wasn't a single event, but a series of dramatic drops and partial refills, driven by this perfect storm of geology and climate. Each dry phase pushed the Mediterranean closer to desolation. The interplay of tectonic uplift and climate cycles set the stage for one of Earth's greatest environmental transformations. The Mediterranean's fate was sealed by forces both beneath our feet and far above our heads. The result: a sea on the brink of extinction. With the Atlantic cut off, the Mediterranean's water level plunged, exposing vast plains and leaving behind a toxic, hypersaline brine. Salt and minerals precipitated out, forming thick, blindingly white layers across the basin floor. In the deepest parts, conditions were extreme: scorching heat, crushing pressure, and lifeless salt flats. Over 600,000 years, repeated drying cycles deposited a colossal amount of salt, about 10% of all the salt in the world's oceans. This Messinian salt giant is buried beneath today's seafloor, a silent witness to the vanished sea. The salt changed the chemistry of the world's oceans and left a geological signature that could only be explained by near-total desiccation. The Mediterranean became Earth's salt shaker, emptied into one giant pile. The buried salt tells the story of a lost sea, hidden for millions of years until modern science uncovered its secrets. The Messinian salinity crisis was a mystery until seismic reflection profiling revealed the truth beneath the seafloor. In the 1960s and 70s, scientists discovered a thick, chaotic layer, the M reflector, stretching across the Mediterranean basin. Drilling deep cores confirmed it was salt, up to 3 kilometers thick in places. The only explanation: the Mediterranean had evaporated, not once, but many times. Rivers like the Nile and Rhone carved deep canyons, now buried, proving the basin was once far below sea level. These rivers flowed down steep slopes to reach the shrinking salty lakes, creating gorges grander than the Grand Canyon. When the sea returned, these canyons filled with sediment, preserving evidence of a vanished world. The discovery of the salt giant revolutionized our understanding of the Mediterranean's past. Modern technology allowed us to read the hidden story written in salt and stone. The Mediterranean's lost chapter was finally revealed. As the sea dried, vast plains and land bridges emerged, connecting Europe and Africa. The Mediterranean, once a barrier, became a crossroads for life. Herds of elephants, hippos, antelopes, and horses migrated from Africa into Europe, while deer and saber-toothed cats moved south. Fossils confirm this great faunal exchange: African species in Spain and Italy, European species in North Africa. Hardy plants colonized the new slopes, supporting migrating herbivores. The basin became a stage for evolutionary experiments as animals spread across the exposed land. But this new world was temporary. The geological clock was ticking. When the waters returned, these animals were stranded on islands, setting the stage for even stranger evolutionary tales. The Mediterranean's drying was a catastrophe for marine life, but a brief paradise for terrestrial migrants. The vanished sea reshaped the region's ecosystems in ways still visible today. The legacy of this migration endures in the fossils scattered around the basin. When the Mediterranean refilled, land bridges vanished and animals were marooned on new islands. These islands became evolutionary laboratories. Large animals like elephants and hippos shrank, evolving into dwarfs to survive on limited resources. Fossils reveal dwarf elephants on Sicily and Malta, and dwarf hippos on Cyprus and Crete. Meanwhile, small animals like rabbits and dormice grew larger, free from predators: giant dormice on Sicily, enormous swans and owls on Malta. This island rule created a menagerie of giants and dwarfs, each adapted to their isolated homes. The only way these animals reached the islands was by walking across land bridges during the Great Drying. Their fossils are direct evidence of the Messinian salinity crisis and its aftermath. Each bone tells a story of isolation, adaptation, and the power of evolution. The Mediterranean's islands became museums of evolutionary oddities. Among the island oddities, one stands out: Neuralagus rex, the rabbit king of Minorca. Discovered in 2011, this giant rabbit weighed over 12 kilograms, 6 times heavier than today's rabbits. Unlike its speedy relatives, Neuralagus was slow, waddling, and nearly blind and deaf. No predators meant no need for speed or vigilance. Its ancestors crossed from Spain when Minorca was land, then evolved in isolation as the sea returned. The rabbit king is a classic case of insular gigantism. Bigger, slower, and perfectly adapted to a predator-free world. But such specialization came at a cost. When new species or humans arrived, these giants couldn't adapt and vanished into extinction. The story of Neuralagus rex is a reminder of evolution's creativity and its vulnerability. The Mediterranean's lost giants and dwarfs are echoes of a vanished world. Their fossils are the last traces of a unique evolutionary experiment. Eventually, tectonic forces weakened the Gibraltar Dam, and around 533 million years ago, the Atlantic broke through. A trickle became a torrent, the Zanclean Flood, one of Earth's greatest deluges. Water rushed in, eroding the channel and refilling the basin at a rate thousands of times greater than the Amazon River. The Mediterranean, dry for 500,000 years, was reborn in as little as 2 years. The flood dissolved salt flats, filled deep canyons, and turned plains back into islands, trapping animals in new refuges. The roar of the flood would have echoed for hundreds of kilometers, a planetary reset in the blink of an eye. The Zanclean Flood ended the Messinian salinity crisis and restored the Mediterranean's marine life. The sea's rebirth set the stage for the world we know today. The Messinian salinity crisis is more than ancient history. It's a lesson in Earth's dynamism and interconnectedness. The buried salt shapes the region's geology, creating traps for oil and gas, and challenges for modern engineering. The crisis shows how life adapts, and sometimes perishes, in the face of extreme change. The rise and fall of land bridges drove migration and evolution, but also left species vulnerable to extinction. The Mediterranean story is a cautionary tale about the fragility of specialized life and the unpredictability of our planet. Tectonic plates still move, and the Strait of Gibraltar remains a temporary feature. While another desiccation is unlikely soon, the crisis reminds us that Earth's geography is never fixed. Climate and geology are locked in an eternal dance, reshaping our world in ways we can barely imagine. The ghost of the lost sea is a powerful reminder of Earth's ever-changing story. Our planet's past holds lessons for its future, and for us.